And we are live. So, waiting for people to join it.
Yep, people
So,
started
guys,
joining. Hi, everyone. Good
hi.
morning, good afternoon, good evening.
Yeah, some of might be in a good night mode as well.
Yep,
Yeah,
especially people from India and Southeast Asia.
yeah. Hi everyone, welcome to the another series of the workshops where today we are going to see how do we do like mint debts and data anchoring tokens basically and private data insurance with LazAI API using LazAI's API, and Thiru is going to take us through the live demo code. And before we jump to the live demo coding, I would like to just give a short introduction of us for those who are new here. So, hi, my name is Nidhi Nakrani. I'm from Devrel Maris, and we have Thiru from Devrel Maris as well. Um, yeah, we do workshop like every Thursday or maybe on a Friday on the same time. So on a different Les AI Inference, Ali, Mary's, Hyperion, different what do you say, topic, or yeah, different um yeah, topics. So before okay, so I think dear, do you want me to wait for some
Yeah,
few?
let's wait for a few more minutes before we start.
Yeah, because
Uh,
we yeah, couple of more minutes. Okay, so before we start, would you mind giving the like brief introduction of like what we are going to see today?
yep, in this workshop, we have two major narratives of LazAI. So one is the DATs. So DATs are, as you mentioned, the data anchoring tokens, and the data anchoring tokens usage is to provide a reward for the data provider, and as well as to track which like data is being used for the computation. So it helps for the verifiable computation as well. And so DATs basically helps data providers to receive rewards whenever the data is being used. So we take any LLM that we use in day to day in our life, we can see like the LLMs consume and then train on the data, basically public data, all the public blogs, research papers. But those providers who like wrote the blogs or written the research paper is not getting credited and not rewarded for their work, even though these commercial platforms consume and train their model on top of them. That's what DATs eliminates. And if using DATs, where data provider, so anyone, if I have data, I can able to provide. So in a sense of I can able to contribute, and for the contribution I will receive DATs as a proof, and the data I provided will be mapped to the DAT. So whenever a particular data I have provided is being used, I will receive the reward through my DAT. So DAT is also the 1155 NFT standards, and so it will provide the reward tokens whenever my data is utilized by anyone. And here we have the inference as well. And there's a cool thing about DATs here is it is also like private. So the data that we provide is encrypted. It is not like publicly available for everyone. It is still encrypted. And using the inference, we can able to do the inference on the inference, in a sense, able to query on the encrypted data that we provide without revealing the data on chain. So we can do the querying from the data that we provide without revealing. So that is the cool part about LazAI API, and everything can be done with just calling the API. And there's a couple of transactions that need to be done. It's a like one-time transaction where we have to register ourselves on LazAI and do the deposit for the query fee. So we will see everything in this workshop. So as I mentioned, it will be a two-part. One is how we can provide data and mint DAT, and followed by the private data inference. So we're going to infer from the data that we provide itself. So I think we can start.
Yeah, let me share.
Yeah.
Okay,
So
okay.
this is the docs that we have at elite.lazai.network. I will share this link in the comments here. So if anyone want to follow, and also in our post after this event, after this workshop, we will have a Twitter post. So we will provide all these content over there. So we have the data contributor flow. Let's look at the workflow of it. So we need the private key and the IPFS hash. So we prefer the Pinata. You can use any other service as well, and we can use Rust, Python, or Node.js. But in this workshop, we're gonna use Python, and we have the demos for like running Inference server and LazAI API as well. We're gonna see it in the later part of this workshop. For this workshop, I have created this GitHub repository. I'll also paste it over here. Okay, this one. So I have provided all the steps to run it. So you can run it with me. First thing we're gonna do is this. We're gonna clone this. I'm gonna share my terminal now.
To run this, like we need less AI token as well, right?
Not it can, so we don't require any like tokens from the APIs. So we just need to install Aleph. So we're gonna see this in this tutorial, of course.
Can you make it a little zoom?
Oh, sure, sure.
Zoom in, yeah.
Yeah, so I'm just gonna clone this repository, and I'll open this in a code editor. Yep. So we can follow along with the readme itself. Is my code editor visible?
Yeah. But
Cool. Yeah.
if you can make it like
Yeah.
z- big enough, zoom in a little bit. Yeah, that's good. Perfect.
Cool. I'll start with the commands I have provided. The first requirement is, of course, Python, and the private key from LazAI wallet. We don't have like a separate wallet. It's like the EVM wallet from MetaMask or any EVM wallet, and we need a IPFS token. So I'm gonna use it from Pinata, and the next thing is you definitely need a testnet tokens. So you can get it from the faucet. I have provided the faucet link as well. So it is a TG bot. Following that, we first need to create a Python env. Followed by that, we're gonna activate it. And next step is we have to install Aleth. So Aleth is a Python package. So Aleth is a SDK that you can use to create AI agents as well as to do AI inferencing. So you can able to do both within a single agent. And once we have installed Aleth, the next thing is to expose our private key as well as JWT. So uh, to say it again, never reveal your private key,
Yeah.
never lose it, not your keys, not your crypto. So I'm gonna stop sharing and export both private key as well as JWT token.
Make sure that we keep it secure. Private key and
Yep.
JWT token.
Yep, I'm exported my private key and I'm exporting my JWT token. So how you can get the IPFS JWT is simple. You can create an account in Pinata, and
Data.
there is like API key section, so where you can create a new key and you can able to copy the IPFS hash. There will be like API keys that is not required for this. You only need the JWT from it. So I have exported. So let's get back to action. Yeah, is my screen visible?
Yep.
Sure, I have exported my envs. The next step is actually running the dat. So before running a dat, let's go through the code. So we have the few packages and the dependencies which is required to run. So the eat messages is to sign the eat message, so to sign the transactions as well, and the necessary packages from alit, especially the encrypt. Pinata encrypt is to encrypt the private data that we provide, and these functions are to upload the data into the ipfs, and the client. So the client module is for to connect alit with the LazAI. So LazAI is a chain. So the client is the module that we use to connect with the LazAI chain, and this variable privacy data. So this is the actual data that we provide. So for this demo, I just keep it very simple, and provided it as a static variable where we just give some data about AI agents as well as Alit. So how Alit and LazAI helps with the decentralized AI narrative here. So this is the content that we are going to provide, but we can able to provide it within a file and then you can use it. So you can easily do it with python. And here we are creating a client instance, we are creating an ipfs instance, and here the data file name. So this is not actually like the file that you are reading within the code editor. It is actually the name of the file that you're gonna store it within the ipfs. So this is basically the label. So we have the data, we need a label for this data. So that is what this file name will be. So this is what the data will be referred in the ipfs. I'm gonna just like keep it like 99. So just to make it unique, so this has to be unique. So followed by we write a simple message and we sign it.
So just
And
sorry to
yeah,
cut it down. Like every time we run the script, this file name should be different.
yeah, so it has to be unique.
Okay.
Yeah. So that so this also to helps to fetch the file without conflict. So that's why we have to make it unique. And followed by we sign the message, and we encrypt the data, that is the privacy data, and we create a instance of ipfs to get the token. So this is where we fetch the token from the environment variable that I have exposed earlier, and we upload the file over here. So this is the file name, the encrypted data, and token. So token is required to upload the file. If the ipfs token is invalid or incorrect, so the execution will fail over here. And once this execution is succeeded, your file is uploaded, we will get the shareable url. So basically the reference for the file that we have uploaded from the ipfs. And once that, we can able to fetch the file id from the url. So this file id, it is the reference for the file that we have contributed, and it will be will be linked with the dat that we minted. So we can able to refer to the data that we provided using this file id. This file id is essential because we can do the inference only using this file id. This is the reference for the data itself. So we will get it in the print statement. And so we sign the transaction, and the file will be stored on chain and in the ipfs, and we will sign the transaction. So that's it. So basically it will run the main function. This is the class. So we have the only thing we have to change over here is the file name. So once that, we can run python dat.py. So as I mentioned over here, that is the next step to run the approach script. So we will so let's debug. So what is the issue over here is, I can see this is with the IPFS upload. So if I go inside, so this is like a minor bug. So this is actually fixed. But I'm using a older version of Alid, I believe. So Alid, yeah, I think I'm using a older version of Alid. So this is actually, this issue is fixed. So how you can like mitigate this issue is just go to IPFS .py, and here I just need to change this as false. So as I was using a older version, if you could install the recent version, the most recent version of Alit, you won't have to do any error fix. So once I fix it and I run the script, so here it will first, I'm sorry, I'll just go into focus mode. Yep, we received the file ID 104. So as we get the file ID, so we are sure like the transaction went successful. Our data is uploaded to the IPFS. The transaction is signed. The DAT is minted. So once it is done, we can copy the file ID, go over to the inference.py. So inference.py, in this file it contains the script to do the private data inference. So it start with, we have the essential modules that we imported from Aleth, which is the agent is to run the prompt, and LazAI client is to connect with the LazAI chain, and we have the LazAI IDAV address, that which is hard coded over here. So this hard coded address, I'll close the screen. So this hard-coded address is actually the inference server that is running on a Fala TEE. So you cannot like change another address. So this is the only one that is currently running. We will provide like more the inference servers, but like that is the later part. But it is the only running server that we have, and we are creating a LazAI client, and the we have the deposit amount. So we will see like why this deposit amount is used. So here we have the client instance, but the client.wallet.address, so how this address will emerge from, it is from the private key that we have exported earlier. So it will look for the private key in the env, and then it will get the public key of it. So that's what this wallet.address will return. Once that, so we will again check for the get user. So get user is to check whether this address have already registered in the LazAI, the LazAI client. So if it is registered, it will print user already exists. If it is not, we will have the add user. So it will sign a transaction, and then it will do the deposit. So the deposit is to run the inference queries, and the deposit inference is to provide uh, like the incentive for the inference server provider. So the inference server does cost. So inference servers is a TE server running on Fala client, and it mostly contains like GPU. So running GPU cost a lot. So there will be like this inference server providers, and we have to pay them to run our request. So that's why we have to do the deposit inference function with the particular inference server that we have to request along with the deposit amount. And we here have the file id. We need to change this file id. So this file id you will receive from the data contribution step. So we have over here the 114. Once that is done, we will get the inference node. So how we get the inference node is, once we have deposited to the LazAI IDAV address. So the each LazAI IDAV address will be registered along with the server URL it will be run. So like any URL like Versal or DigitalOcean, so it will also have a URL. So let's say something with like Fala. So we will get that, so that we will get it from its the first position. It's like the second position actually, from like 0 and 1. So it will be in the second, and we will print it just to check, and we will also check the inference account. So this is to double check whether this particular client, so the client is nothing but the user, have uh, a deposited amount within the particular inference server. So how this works is like we have to deposit some money, some tokens, let's say like 0.001 LazAI tokens, to a particular inference server. So once I have deposited, so I will be added to their inference accounts, in a sense that the number of accounts, or like the list of accounts that have the ability to do the inference from this particular server. So we will double check that. So if we have the deposited, we have a valid client, we will receive the account details. If not, it will return a warning. So once we have checked all the details, we will create a agent instance. Here something to be noted with, we are mentioning the DeepSeek R1 model here. So how someone can be sure which model should be used? So this model have to match with the inference server that is currently running. So the server that we have the model DeepSeek, so we have to match it. So if our inference model is OpenAI, and if we use, so not like OpenAI, like let's say GPT-4o, and if we send a DeepSeek model, it will throw an error. So we have to match it. So how you can find it is, we can check it with our LazAI website. We can provide like uh, each inference server along with the model that it runs, so you know like which model to be passed. And you don't have to change anything else, because it is like base URL, that is the inference URL. And we are also sending the extra headers, which have the LazAI IDAV address followed by the file ID. So why we are sending is file ID here. So this is the context that we are providing to the model, so that it will understand the context, and it will provide the response for our request. So we are sending a prompt, basically what is it, or we can also do like summarize it. So I have, so I just make sure I have changed the file ID. Now I'm gonna run inference.py. So first it got my wallet address. Okay, my account is already exist, I've used it previously. And you can see it have fetched the inference URL, which is the Fala.network. It is hosted in Fala.network, that's why you can see the domain over here. And we have the inference account, and this inference accounts make shows we are in a list of accounts that have enabled to do the inference query. So our query is being processed. Yep, we have received our response over here. So as we have provided the summary of as we asked for the summary, it is provided the summary of Alet, because that is the data that we have provided. And last AI gateway, and powering contributors, AI is scalable. Yep. And uh, to make it like more interactive, so we have provided data file. So there's like another file I have provided like previously. So it contains like data of like some TV show. It is called Naruto. So if I have asked to summarize that, if I run the inference server again, so this is the previous data that I have used for testing a long time back. So similarly, it will again check for the user wallet address, and the user is already existed. So it fetch the URL. So the same process all over again. Yep, let's wait for a couple more seconds. Yep. So we have the response over here. I mean, I don't think I need to explain like Naruto Uzumaki, but so this is just to test like the inference model's behavior. So if we provided a data and if we can able to do a query on it, it will understand the context and it will provide the response on it. So we can see it provided the major characters, goals, highlights, examples, and like the significance, everything through it. So this is the example of text-based data contribution and inference. You can also provide like CSVs and even like different type of data within the private data, and you can able to do inference on it. Like if you can provide like a CSV on CSV data on like uh, on a like a different like healthcare modules, and you can able to do inference on it. So that is like the game changer, along with you can able to run an agent at the same time. So both can be done with the Alit SDK. Do we have any questions?
I answered and comment. Uh, yeah, I think they are understanding everything.
Awesome. Yeah. I mean, there's like nothing better than that. So we have provided the GitHub repo for this as well, so you can go through it, and if you if you like got any issues with it, you can also reach out to us through our Telegram. I'll also paste the Metis Telegram account over here. So there's a Metis developer group. You can reach out to us through this.
Yeah, feel free to reach out to us for any issues, any feedback, any comments.
Yeah. And so we have the Alit integration bounty, which is like the TK. So you can able to integrate the LazAI inference as well within your agent or the dApps that you are building. So if you have like any particular questions with the integration, you can reach out to us through TG. We'll be happy to help you out. Awesome. If we don't have any questions, I think we can wrap it. Do you have anything to add on, Nidhi?
Not from my end. Yeah, all good. I think
Awesome.
if we don't see any question or comments in the comment section, I think we can wrap it up.
Yep, we don't have any questions so far. Cool, cool. Cool then. So we can meet again in the next workshop on Thursday, and we also have vibe sessions on Tuesday.
That's right. Yeah, yeah.
Cool.
See you guys on the vibe sessions and the next workshop. Bye, guys.
Yeah.
Take
Bye
care.
bye.